In 2025, Consumer Reports confirmed what veteran technicians have been warning about for over a decade. Brand new air conditioning systems are failing years before their warranties expire. Class action lawsuits have been filed against nearly every major manufacturer. Goodman faced potential damages exceeding $803 million. Carrier settled a defective furnace case covering 3 million consumers, and Lennox was forced to redesign its entire evaporator coil line after a wave of premature failures. Why does a system that costs the contractor roughly $4,000 get installed in your home for $12,000? Why are manufacturers quietly replacing copper components with aluminum that corrodes in half the time? And why does the rest of the developed world use a completely different technology that America's HVAC industry has spent decades fighting against? We are going to expose the engineering decisions destroying your home comfort system and show you the 3 types of equipment that are actually worth your money. If you have ever called around for quotes on a new air conditioner, you probably received 3 or 4 bids from different companies, all recommending different brands. You see names like Carrier, Trane, Lennox, Goodman, American Standard, York, Bryant, and Amana. And you assume these are independent manufacturers competing to build a better product for your home. That is an illusion. The reality is that 5 massive corporations control nearly 80% of the entire North American market. Trane Technologies owns both Trane and American Standard. Daikin Industries, a Japanese conglomerate, bought Goodman for $3.7 billion in 2012 and now controls both Goodman and Amana. Carrier Global owns Carrier, Bryant, Heil, and Payne. Johnson Controls sold York, Coleman, and Luxair to Bosch for $8.1 billion in 2025. And Lennox International owns Lennox, Armstrong, and Duquesne. When you think you are comparing 6 different companies, you are often comparing 3 subsidiaries of the same corporation wearing different logos. And the consolidation does not stop at the factory. Private equity firms have been aggressively buying up your local HVAC contractors, keeping the trusted family name on the truck while implementing corporate upselling targets behind the scenes. 2024 was a record year for these deals. One firm made 28 acquisitions in 3 years. Another completed over 35. The local technician you trusted for years may now be working under a corporate scorecard that rewards selling you a full system replacement over a $200 repair. But the illusion of competition is not even the worst part. The real damage is happening inside the equipment itself. The air conditioner your parents bought in 1985 was built to last a generation. Industry data confirms that units from that era routinely survived 25 to 30 years with basic maintenance. Today, the National Association of Home Builders puts central air conditioning lifespan at 10 to 15 years. ASHRAE's median estimate is 15 years. The Department of Energy uses 15 years in its life cycle cost models. That is roughly half the lifespan in just 2 generations of product development. Veteran technicians confirm it bluntly. One 30-year contractor stated that equipment certainly does not last like it did decades ago, and that is a fact. Another wrote that older systems lasted 20 to 30 years, but the newer refrigerant equipment lasts about 8 years or less for the indoor coil. And this was not an accident. It was engineered. Part of the problem is the refrigerant itself. The replacement chemical operates at suction pressures nearly double the old standard and discharge pressures exceeding 400 pounds per square inch on hot days. Those higher pressures stress every joint, fitting, and coil connection in the system every single day the unit runs. But the deeper sabotage happened at the material level, and most homeowners never learned about it. Starting around 2006, manufacturers began replacing copper evaporator and condenser coils with aluminum. Trane led the switch for indoor coils. Carrier followed around 2013. Goodman, Lennox, and Rheem all moved significant portions of their product lines to aluminum. The reason is simple economics. One coil manufacturer explained it plainly. Aluminum costs roughly the same per pound as copper, but you use 3 times as much copper in a copper coil. The savings go to the manufacturer. The consequences go to the homeowner. Copper coils from the 1980s are still found leak-free when technicians pull them during system replacements decades later. Modern aluminum coils in coastal or humid environments have been documented failing in less than a single year. When an aluminum coil fails, you cannot just solder the leak the way a technician could with copper. The entire coil must be replaced at a cost of $600 to $2,400, or $2,500 to $4,500 without warranty coverage. One Goodman owner reported both indoor aluminum coils lasted only 4 to 5 years, and the outdoor components lasted 9. But cheap coils are only half the engineering problem. Every modern air conditioner depends on electronic circuit boards that have replaced the simple mechanical contactors and relays of older systems. Those old mechanical parts cost $20 to $50 and lasted decades. A replacement control board today costs $250 to $1,300 installed. High-efficiency communicating system boards can exceed $2,000. These circuit boards fail from power surges, humidity, overheating, and even insects crawling inside the unit. When the board dies, the entire system goes down. ASHRAE's own data confirms electronic controls have a 15-year median lifespan versus 20 years for the mechanical controls they replaced. Manufacturers did not make this switch because electronics are more reliable. They made it because electronics are cheaper to manufacture and create dependency on proprietary replacement parts. Now here is where it gets truly expensive. Every refrigerant transition in the last 3 decades has forced a multi-billion-dollar replacement cycle, and the pattern is about to repeat. R22 was banned from new equipment in 2010 and from all production in 2020. R410A replaced it. But here is a fact that should make you furious. R410A actually has a higher global warming potential than R22. The first transition addressed ozone depletion while making the climate problem worse, which conveniently set up the next profitable transition. Now the AIM Act of 2020 mandates R410A's replacement with R454B, with new R410A equipment banned as of January 1st, 2025. The price pattern is predictable. R22 went from $10 per pound to over $200, and R454B is following the same script, surging from $345 per cylinder in 2021 to over $2,000 in 2025. Some contractors could not source it at any price during peak cooling season. The critical detail that almost nobody talks about is who profits from this. Honeywell and Chemours, formerly DuPont, hold most or all of the patents on R454B and its key component. Only these 2 companies can legally manufacture it. The Competitive Enterprise Institute documented that these 2 chemical giants led the lobbying effort for the AIM Act alongside environmental groups, and that the Act's prime sponsors represented states where Honeywell and Chemours have major operations. In 2025, 2 refrigerant distributors sued Chemours and its partner for anti-competitive conduct, accusing them of complete control over R454B supply. Meanwhile, Daikin opened its R32 patents for free global use, and R32 is available at roughly 1/4 the price. Yet approximately 75% of American equipment adopted the patented option instead. You might think the warranty will protect you from these failures, but first you need to understand the markup that makes all of this so profitable. A typical 3-ton residential system costs the contractor roughly $4,300 to $5,300 at wholesale, including equipment, materials, and labor. What homeowners actually pay is $8,000 to $14,000. Premium systems reach $25,000. The industry targets 50 to 55% gross margins. A $25 wholesale capacitor sells to a homeowner for $75 to $100. That is the $12,000 secret. You are paying double to triple the actual cost, and the warranty system is designed to protect the manufacturer, not you. Every major HVAC brand advertises a 10-year warranty. What they do not advertise is that you must register that warranty within 60 to 90 days of installation, or it automatically drops to just 5 years. Even the full 10-year warranty covers parts only and never labor. Since labor now exceeds 55% of total project cost, a covered compressor replacement can still cost you $1,500 or more in labor alone. Without warranty, that same repair runs $4,000 to $7,000. The fine print goes even further. Most manufacturers require proof of annual professional maintenance, and using unauthorized parts or non-certified technicians can void your coverage entirely. And here is the most damning statistic of all. A Department of Energy research review found that 70 to 90% of air conditioning systems have at least one performance-compromising fault introduced during installation. The very defects most likely to cause early failure are exactly the defects that warranties exclude. Florida is the only state that has enacted meaningful protection, passing a law effective July 1st, 2024, stating that failure to register a product does not diminish warranty rights. No other state has followed. So if the entire industry is engineered to extract maximum revenue from your household every 10 to 15 years, does that mean you are powerless? It means you have to stop shopping like a homeowner and start thinking like an engineer. There are 3 approaches that will save you thousands and deliver equipment that actually lasts. The first option is the technology that most industrialized nations already use. Ductless mini-split heat pumps from Mitsubishi, Fujitsu, or Daikin deliver 20 to 42 SEER efficiency, which is nearly double the best central air conditioners. They eliminate the ductwork that federal energy studies say wastes 25 to 40% of your cooling energy before it ever reaches your rooms. Japan has used mini-splits in over 90% of homes for decades. Norway heats 97% of its homes with heat pumps. Mitsubishi's hyperheating technology delivers full capacity at 5 degrees Fahrenheit and keeps running down to -13. A single-zone installation costs $2,500 to $6,000. A whole home multi-zone system runs $10,000 to $15,000, which is comparable to a central AC replacement, but with dramatically better efficiency and reliability. The second option is to buy central AC if you must, but prioritize installation quality over brand name or SEER rating. Here is why. SEER ratings are tested under laboratory conditions with almost no duct resistance. Real-world ductwork creates 5 times the resistance, meaning a 20 SEER unit connected to typical leaky ducts performs like a 12 or 13 SEER unit. The premium for a 20 SEER system over a 16 SEER saves roughly $67 per year in electricity, with a payback period of nearly 13 years, which often exceeds the equipment's lifespan. Instead of chasing SEER numbers, demand a manual J-load calculation, which is the engineering standard for proper sizing that most contractors skip in favor of rules of thumb. Oversized systems short cycle, waste 15 to 30% more energy, and die years before their time. Get a minimum of 3 quotes, verify NATE certification, and confirm the contractor will commission the system after installation, meaning they actually test and verify performance rather than just turning it on and leaving. The third option is the most expensive upfront but the cheapest over a 30-year horizon. Geothermal heat pump systems deliver 300 to 400% efficiency by exchanging heat with the constant temperature underground. The underground loops last 50 years or more. Indoor components last 20 to 25 years. Installation costs $15,000 to $40,000, but energy bills drop 40 to 60% immediately. There is one more detail almost no one mentions. Geothermal systems increase home resale value by $15,000 to $25,000, according to appraisal studies, meaning a significant portion of the installation cost is recovered if you ever sell. Across all 3 options, there are rules every smart buyer should follow. Avoid proprietary communicating systems like Lennox iComfort, Carrier Infinity, and Trane Comfort Link. These use closed protocols that lock you into $800 to $1,200 proprietary thermostats that cannot be replaced with a standard $100 alternative. Install a whole house surge protector to protect those fragile electronic components, and choose R454B or R32 refrigerant systems to avoid yet another forced replacement cycle in 15 years. The era of 30-year air conditioners is over. The big manufacturers are counting on you to be dazzled by efficiency stickers on the box so you do not notice the aluminum coils corroding inside the cabinet. They are banking on you not reading the warranty fine print until the compressor fails at year 6. And they are hoping you never discover that the rest of the developed world has been cooling and heating their homes with superior technology for decades. But now you know. Do not hand $12,000 to a corporation that has engineered its product to fail just past the warranty period. Check the coil material, check the refrigerant, demand a manual J calculation, and never underestimate the value of a technology that Japan and Norway figured out 40 years ago. If you found this video valuable, hit subscribe so you do not miss the next investigation, and share this with anyone who is about to spend thousands on a new system without knowing what is really inside the box.